So Dr. Cosgola sent the second part of his presentation in the chat. You can see it there. But it's not where we're gonna start today, and I'm gonna also make some announcements. But first of all, good day to you guys, and welcome back to our second session of today's webinar. I hope that you were able to receive the presentation, a copy of his presentation, as well as the link for the YouTube recording for yesterday's session. If not, please look into check your spam folder because we sent it using the email that you have registered when you asked to participate for this session. So welcome to the second session of our workshop. So while waiting for others to join, we invite you to visit our website at www.icuddr.org and know more about our organization, the International Consortium of Universities for Drug Demand Reduction. You can also watch webinars, conference, and workshop recordings, as well as access drug demand reduction related resources such as recent researches available in public domain. We are also inviting faculty members from higher learning institutions to sign up for membership. So just as a reminder for some guidelines for today's event, please make sure that your microphone is turned off. And if you have any question all throughout the course of Dr. Cosgola's presentation, type your questions in the chat box and our speaker or Caleb and I will try to address them during his presentation. So the workshop is being recorded and we will send you a copy of the video link, just like earlier what we did today. We will also have a 15-minute health break in between the 3-hour workshop. Lastly, translation for closed captions for various languages are available. To turn on this feature, click the CC caption icons at the bottom of your screen, or if that's not showing up, click the 3 horizontal dots or the More icon. Then you can turn on translation and select the closed caption languages of your choice. So I hope that you were able to review yesterday's presentation, and we'll continue where we left off. So let me turn the floor over to our amazing facilitator, Dr. Cosgola. Dr. Cosgola.
Okay, so sorry, I muted myself. Okay. Good evening, everybody. So thank you again for joining. And I would like to start it from the slide that that we didn't finish. I think it was right here. So I think we completed this activity. Getting the sum and using different loop functions, and we talked about if and else statements and for, while, and repeat loops. So the next part is actually writing a custom function. So custom functions are very broadly used, widely used in many programs in Python. Basically, like a lot of packages are developed based on this function. Whenever we call some sort of a statement or some sort of functionality, or in, let's say, like using dplyr. So if you want to call some sort of a functionality, so it's actually calling several sets of functions. It's being written by other people, that who developed all these packages that we talked about yesterday. So that's why you will see like only one command line. So where we call multiple functions within those functions, we have a lot of functionalities, a lot of steps that's included within each function. So this is a little bit like this is a little bit of an advanced topic, but we are just learning what the functions are and know what they can do. So we don't have to develop our own functions. That's not a requirement in this basic course, but I just really want you to know these things exist, and behind the scene these things work when we run our code. So a lot of functions will be called, and they within one function there would be like several multiple functions, and likewise you cannot even imagine how many functions are being called um, in when you execute one command. So that being said, we can see the typical definition, the standard definition of a function. So we can see right here. So this is how you write a function. First, you have to write a name of a function, whatever the name that you want to give, you give that name, and then you have to type function, and then you have to give arguments that you're going to pass. Like arguments are the values that you're going to pass to a function. So a function is going to carry these arguments, and then so inside these brackets, so it's going to do some sort of an execution, like so whatever the things that you write here, like it's basically doing a set of commands. So things that we wrote earlier. So similar to that, you have a set of like commands, like codes that you execute, but it's going to use this argument. So within these brackets, whatever we do, it's going to engage these arguments that we use here. Okay. So this is an example right here. See, add numbers. It's one simple function. So what it does is actually like, we are passing A and B arguments. So A and B are nothing but numbers. So what we are doing here is you can see like simply we are, adding them, and then assigning the added, value into the sum variable. Okay. So, and then we are returning a value. So always a function should return a value. So what is it returning? It's returning the sum. So that's what's returning. So we are, what we are giving the function is actually these arguments, what A and B, and in return, it's going to give us the sum. Okay, it's one simple function, but within this function, we may have multiple command lines, like several codes, several computations, engaging all these arguments that we pass. So but this is one just simple function. Okay, so yeah, so it's going to print, if you run this command, you will see like, the results, like the sum is going to be printed. So let's try to run this and see how it's going to work. Okay. Okay. So you can, again, like I'm giving you all these commands. I'm not asking you to like write your own commands. I just want you to do what I'm doing, and I'm just copying and pasting everything. You just have to run, whatever I have prepared here. So this is a very simple function that I wrote for you. You just have to run it. So let's say the name of this function is add numbers. So we have to make sure we are going to use this name when we call the function. So you cannot have the same name um, for another function. Okay, so they should be the name should be unique. So otherwise, it's going to be like kind of be overridden. So you won't be able to use two different functions with the same name. Okay, so so now if we run this, you will see that function is being added, right? So in the environment, pane, you can see the function is being added, but nothing is doing, like, it's not doing anything. So because we have to, just because we have a function defined, that doesn't mean that we have an outcome. So we have to call the function, and then you have to pass these arguments. So we have to give the values for these arguments. So the first argument is A, the second argument is B. So you can see you don't have to define what A and B are. Basically, you just have to give the values of A and B. When you pass like A and B into this add numbers function, it is going to sum, as you saw here. This simple summing function. So I'm going to run it now, and then you will see the results, right? So we can now print right here. Result is already shown here in the environment. Okay. So now if you print this, you can see it's 8. So 3 plus 5 is 8. You can change this and add um, any numbers, like we can assign any number to A and B, and then get the result. So you can see it's going to add it. So it's a very simple function. So you can just understand what a function is, and you don't have to write your own function, but this is a really good example for you to understand what functions are. But in real life, when you work on, on a task, let's say you have a set of data that you have to analyze and get the results. So you most likely don't need to do this kind of work, basically writing your own functions. But um, if you are interested, you can learn about functions, and you can write your own function to do your own work. So mainly, like you can prepare your own function to do some computations using data or things like that. Okay, so those are like the basics of R. But like I said before, in those packages, all these people who know the programming languages, they have written all these functions for us. So we can simply use those functions without really writing our own functions. So when we call some sort of, like, let's say, finding a mean, right? So it's in the base package, right? It's actually a function that's written by those people who wrote the R base package. Okay. All right. So let's go back.
Dr. Kusgola, there's a question if they can use other alternatives at sum, for example, multiply.
Yeah, you can. So try them. So I'm not going to do everything. You can just try everything, and you should be able to. These are really interesting. I mean, you just have to change this to multiplication. You can multiply, and then see if it's going to work. So if you are interested, like you're asking these questions right now, that sounds really interesting. So you have the code and try it. I won't do it. So I can do it, but I don't want to, because I want you to try it on your own. So just change this to, like multiplication, and then you can change this to, like multiplication, this the return, and then you should be able to multiply it. Okay, so that's a really good question. You can definitely do, like that, and you can also add multiple steps here, not just summing. If you want to, like first do summation, and then you just want to multiply and then add everything, so that can also be done. Like I said before, you can have if and else conditions and different kinds of things within this, like within this function. So it will execute whatever you put inside the function with these arguments. So the beauty of these functions is actually you can carry these arguments, and then you just have to assign those values into arguments, and then it will process all these steps within the function, and it will give the outcome. Okay, so that's why we use functions to make things easy. Okay, all right. See, this is a multiplication function. So I'm actually getting the square. So you don't have to really um, multiply within the function. This is like this. It's you are writing it, this function like this, returning square. So you can try this one also. I'm not going to try that. So you can just have to copy and paste into environment and run it. Okay, try that at leisure. So this is also an activity for you to find the factorial of a number. So if you are familiar with a little bit of like mathematics that we did in, I think factorials were done in middle school and probably 8th grade, right? So, um, um, so that if you remember that, you will understand what this is. So this is how to find a factorial of any number. This function, if you write, I can just show it to you. But again, you don't have to really, if you're not into math, you don't need to worry about this, okay? So this is showing this function, which is called factorial function. What you do is, you if n equals 0, that means if n equals 0, return 1. That means, if the number is like 0, factorial of 0 is 1. So that's what it's asking you to say. Else, so you have to just multiply, from the highest integer to the lowest integer. So from 5, let's say n is 5, so it's going to multiply 5 times 4 times 3 times 2 times 1. So that's what it's doing in this loop. As you can see here, within this function, we are doing this if else condition, and then also we have a loop here, see? So we can do a lot of things here. Don't be confused and don't find it really complicated. You don't have to write any of these things. I can write it because, I have done programming as an engineer, but we don't expect these things, from, people who are in social science domain. So, I mean, if you're interested, it's also not difficult to learn. So these are the things that you can play. Just change something here if you want to try and see how it's going to work. At least do that, and I would recommend you to do that. Let me run it and show you. Hold on. This all right. So it's going to show you factorial of 5, factorial of 5. So it's 120. So if you multiply 5, 4, 3, 2, and 1, you will get 120, right? So that's what it's doing. So I really would like you to, if whenever you have time, just play with these functions and see how they work and change it and try to understand. So this is actually going back to yesterday's lesson where we talk about if conditions, conditional statements, and then loops, right? For loop, and then if, and then we also have function. So pretty much everything is included here, the concepts that we talked about. Okay. So there's other activities, I have added several activities here, and I'm not going to do any of these things because, you may find it like, a little bit like, hard to wrap your brain around since this is our second day. So, but this is there for your reference. Okay, so I can maybe let's try one if you want to try it yourself. I think this would be a good activity, the second activity. So let's try to do this and see how it works. Okay, so I can give you a few minutes to write this function by yourself. You can actually copy and paste. Okay, you don't have to write it, but just copy and paste. There's some stuff in my way, so I'm just gonna move them and then clear this environment so it's clear. All right, so this is easy. So this is not very difficult. You can see. So what we are doing here, actually, this is not a, hold on, this is not a function, hold on. It's just a conditional statement. All right, so I think we did this yesterday. Hold on, I haven't created a function from that. This one, okay, this is also, yeah, this is also a conditional statement. Sorry, I thought I prepared a function. Yes, so for some reason, I cannot find that right now. Oh, okay, factorial. Okay, this one. Okay, so this is the function. So this is, sorry, this is the example that I prepared. So you try this one also. This is related to what we did yesterday. So the first one, this is like if else condition. So you can do this and find a grade. but this is actually related to functions. So what you are doing here is actually determining if a number is the prime number. So so this also has some sort of mathematical uh, uh, computations. So I don't know if you're comfortable with it. Um, I'm just thinking maybe I thought I prepared, my apologies, I thought I prepared an easy function for you. Can you give me 1 second? I can take a look at one. Okay, just 1 second. Okay, I have one. Let's do this. I prepared this one, but I actually have forgotten to include that into slides. So I have it in my notes. Okay, so this is easy.
Dr. Kusgola,
Yes,
may we request that you type that also in the chat box so that they can just copy and paste? Thank you.
yes, of course. Yes, I can. So this is what I prepared, and I know I forgot to include that. So that's what I was looking for. So it's right here. So you can try that. Um, wait, what am I doing here? Hold on. Okay, all right. So this is a function. So this is just to calculate the radius of, um, uh, sorry, the area of a circle, right? So knowing the radius. So it's very simple equation. So I have to put it in the chat. 1 second. Yeah. So, okay, so it's right here. So you can copy and paste it from the chat. So let's try this. Okay, so what we are doing here is, the name of the function is calculate area. So we have to make sure when we call this function, you have to use that name. So that's the name that's given. And then the argument is radius. So you have to give the radius. What's the argument? So that's the radius, what's the dimension, right, of the radius. So you have to give that. So calculate area using the formula. We all know that it's actually like, it's pi and pi times the radius to the square, right? So we know that. So that's equal to area. So we can simply use pi here. So because it's going to be identified, or else if you remember the numerical value of pi, you can type that also. So R can easily identify if you just say what pi is. So that's enough. So it's going to recognize what this value is. You can also say 2.7. That's also fine. And then it's going to return the area. So this is simply you're calculating it, and then you're returning it. So you can try this and see if you're getting the results, and then change the radius and see if you're getting the results. Maybe you can manually calculate, and then you should be able to get the results. So first I'm going to run this and get the function into the memory. So now the computer knows what the function is. And then first, here you can define radius, or you can just give 5 here. So it's not really required to define the value of radius. You can just simply type that also, here, instead of typing radius. Okay. So now we'll find the radius. It's going to show us radius is 5. And then the area we can find, area is 78.539, right? So you can find that easily. So why don't you try this in your environment and check if you can get the answer, please. And then change the radius and try to find it, find the new area. I'll give you a few minutes, okay? Try that.
Dr. Cosgola, there's a question. Where can we get the list of function codes that our studio could use?
Uh, where can we get the list of functions that our studio could use?
I think it would be for the next few sessions, right? And then some of it I can provide cheat sheets as well.
Yeah, so there's lots of functions that you can use. So I think I explained that a little bit yesterday. So whenever you have, I think remember I was talking about multiple um, packages that we can use. So if you go to the manual of each package, user manual, it's going to show you all the functions that it has. So basically, like it's a PDF document mainly, like mo mostly they prepare PDF documents, so you can just search, whatever the functionality that you're looking for, and then, within the document, you should be able to find the corresponding function that you need. Okay. So yes, we can also provide a cheat sheet of everything, but each package that we talked about yesterday, any package, they usually have a user manual. If not, at least they have a web page that's explaining, what it can do. Okay, the package. So and it's a functionality. So you just have to use each function with all these arguments that you can pass.
And this is our program is very extensive, so we can provide you with everything. But right now, what we're doing is building it from the fundamentals, from the basic, and then as we move along further, you will be able to see more of it. And then there's a question, Farida, what do you click to get the result? Is it not in your global environment? Kindly check. And again, guys, just like yesterday, if you are having difficulty, not only can you type your questions, but you can also send us an image of the screenshot and we'll try to help you. Thank you.
Mm, Okay, so I hope you managed to run this function and get the results. Hopefully we can move on now to the next part. So I think we are almost there now to finish this presentation. So I think I have, yeah. So there's some, yes, discrepancy between the slides that I provided and what you see here, because I think I have accidentally, like, created. So I know when I created this presentation, so I had multiple files or multiple documents. So then I had to merge them. So I probably must have duplicated some file, I mean some slides. So that's probably why you don't see the same slide number as you see here on my screen. Okay, so sorry about that, but it's the same content. Nothing has changed. You didn't miss anything. So it's everything is there, whatever you have. Okay, so the next topic is the data, like importing and exporting. So we need to understand this very well. So because most of us, you collect data, you own data, or you are going to use secondary data from another source, someone else's data, publicly available data, or the data that you're getting from your organization. So it's going to come in some sort of a data format, right? In a file stored in a in a computer format, right? So it could be a CSV file, or Excel file, or maybe any other. There's multiple data types, file types that you can store data. So, but R can handle pretty much all of them, at least I would say most of them. But we need to understand how to import a data set that you received in a file from another environment or wherever that you're getting your data from. Okay, so that's the aim here. And then we also need to learn how to export data from our environment to the other places, in case you have to export it and give it to someone else, or you have to use a different platform, or maybe you have to process your data, and then you have to create, get a subsample of the data, and then you have to present it. And in such cases, you need to learn how to export. So importing and exporting are really important. So these are not difficult at all. So these are, again, we are using these simple functions here. So first one is actually a CSV file. So you can read a CSV file without having any package installed, because our base package has read CSV. So you don't have to install anything. So this function, this is a function someone created. So you can basically use this function, with this argument. So that's where you understand, that this is why it's important to know a little bit of basics. So, and in that function, these are the arguments that we are passing. So you can see when we pass this argument, so you can see we are giving the file path to CSV, and then we are going to say if it has headers or not, and if it is separated by comma or something else. So usually if it is a CSV file, it's comma separated, right? So that's why you put a comma here. So this is like the typical uh, expression that we use to import data. So when you run this, it is going to create a data set after importing whatever is there in the CSV file. So then you can read it in your R environment. Okay. So this is how you read data from CSV file. And then Excel file, that for that you are going to use a library called read Excel. So that library, so you don't have, the base function does not have the ability to read Excel files. Usually, like, when you have an Excel sheet, we can easily convert it into a CSV file, and then you can import it into R easily. So, but if you really want to import an Excel sheet, we have to make sure that it contains multiple sheets. So you have to make sure you handle that properly. Okay, so which sheet you are going to import? You see sheet 1, sheet 2, you have to pass these arguments properly. So when you search this, no, if you go to Google and then if you search this read Excel or documentation, it will give you, this know how to do, the explanation. It is going to guide you through the process how to do this. So you don't have to remember. Like I said before, none of these things are meant to be memorized. Okay, so you can easily find. You just have to know these things can be done. So then you can, like, go to Google and search. Okay, so importing, an Excel sheet, and then it will pull up this documentation. Read Excel, and then you they also give you examples, really nice examples that you can use. So you just have to change these arguments to match with your environment, correct file path. So you don't have to actually deal with the file path itself, because when you work inside that project directory, so you can easily just give the name of the file. Okay, that's all you have to do. That's how you import an Excel file. And there's also other formats. There's TXT format. So you can use a read table, if it's in TXT format. And for that, you have to also identify, if it has the header, if the data has a header, and what the separation is going to be. Usually, text files are separated by, the space. This is in space. It could also be comma. Sometimes people have, text files also comma separated. So then it will work. So here, this is a base package function. So you don't have to import any other package. Okay, so that's about importing. So we'll have an example. We'll do that later, but let's see how to writing data to files. So first we'll talk about writing data to CSV files. So this is also included in the R base package. So write CSV, write.csv, and then these are the arguments. You have to give, like, what is the data. So this is actually already there in your environment, data you already created, and then you have to give the file path name, file path, and then the file name, and then you have to tell if the row names are there or not. Okay, so if you already have row names in your data, then you have to say it's true. Okay, so this is an example of writing an Excel sheet. I have never done this because I never had to. People usually don't use Excel sheets like this, but just in case you want to use it, it's right here. But I know if you have a CSV file, you can easily open that in Excel, right? So you don't have to really use it. I have never done this in my life. I don't think if it's even necessary for anybody to do something like that. Okay. And then to save it to text file. So that's also like not really necessary. I mean, when you have a CSV file, you can open it in Excel and convert it into a text file, or however you want to do it. You can also open that in Notepad and then save it as a text file, right? So those things can be easily done. So you don't have to deal with all these mess. Sometimes it could be messy. So one of the most reliable file types are CSV files. So even the big data that we handle, like millions of records that we handle, we get them, in CSV file, sometimes even text files. So it's that's they're easy to handle. So if you work with Excel, I don't know if it's gonna, like, be really 100% accurate or easy to do, because there could be some formatting issues that you may have to deal with. So here is an activity. So let's do this activity together. So I'll show you what it does, and then you can try it yourself. Okay. So it's also writing and reading. It's doing both. So everything is in here. Okay, I'm going to clean the environment so that, it would look nice. Okay. All right. All right. So here, we are creating a fabricated data set. You can see, so this data set, so this is the name of my data frame. So data.frame, it's again, this is a function, and these are the arguments. You can now understand all these functions clearly, right? So we see functions everywhere, right? So the first argument is actually, this is the first column, right? So it's ID. It's the ID going from 1 to 10. So you can see it's increasing from 1 to 10. And then you have name. You have to give the name. So there should be 10 names because there's 10 IDs, 10 names. And then you give age, and then you give age of 10 people here, and then score, what their score is for a test score, something. Okay, so this will have, this data set, if you run this, you will have um, a data set that has 4 columns and 10 rows, right? So if you run this, you will see that. See, it has 4 variables and then 10 observations. So you can see ID. So it's in chronological order, 1 to 10. And then you have name, the first name, and age, and then the score. Okay. So now this is here now. The data is there in the environment. So we have to save this into a file. So how do we do that? So that's what we are going to do now. Okay. So right here, it's very simple. So you just use this write CSV. So because we are going to save it into a CSV file. And then you have to give the name of the data set. It's data. So that's this argument. And then comma. The next argument is the file path and then the file name. So in our case, we don't have to worry about the file path because file path is our working directory, right? So it will be saved there. We don't have to change that. But if you want to save it into a different location, you can manually enter the file path here. But I don't think if it's necessary because you can always go to your work directory and then using File Explorer and then find where it is, okay? And then copy and paste our email or however you want to do it. So raw names false because we do not have raw names in here. Okay, so if you write this, so now it is saved. So we can go in there and see the file. I think it's in desktop right here. Our projects workshop. This right here, it's fabricated data. So we have the file here. Okay. So now you have it. And then again, now we are going to import the same data. See, it's now writing is done. So now we are importing it. So how do we import it? So we are just gonna give the name of the file, so read CSV, and then you have to identify where it is. You can say like if there's names, if you have names headers, you can say true or false. You don't have to do that, but if it is there, it's going to automatically detect. So let's import this. It will be imported into this imported data set. You will see another data set calling the imported data. So it's going to be the same data set that you will see. So you can see the same thing, like right here. So this is the data set that we saved, right? So on my screen, you can see that's the data set that we saved into that, that directory in the computer. And now we import it into, the R environment workspace as another data set using that same file. Importing and exporting is done here, but usually you don't do this. So this, the importation usually comes, from another place, right? You don't have to do this here. So, but I just wanted to show you, this is how it is done. So you can also do some manipulations. So I can show you. So now if you get, head is another function. Okay, so these are all base functions. And then the argument is imported data. So like the data, and then you can see when it will just show you the first, few records when you do that. And then if you want to modify the data frame, I mean, there's multiple ways of doing this. You can use, you know, um, functions and like mutate function in dplyr, or you can also do it this way. So it's a simple way. So what we are doing here is, you just add 5 to all the scores. So for example, so right now you can see the scores are 85, 90, 78, like that. And if you add 5 in, like, to all of them, all the scores, that means for the entire column, score column, with the 5 will be added. So if you run this, you can see now, see 85 became 90, 90 became 95, 78 became 83. Likewise, there's 5 added to the entire column here, right? Okay, and then you can write this modified CSV. So, and then you run it, then you should be able to see that file also. So you can also see the files right here. So, on this pane, as we talked about yesterday. So you can see the modified data, like CSV file is right here. Okay, it's being saved. And we can go to files. And if you refresh, you don't have to refresh, it's actually here. So modified data set right here. See, score now is being changed. So it's 5 is added because we did that change. Okay. These things are really simple, and definitely you need these things. So anybody who works on R will use this. So you cannot say, I don't want to use that, because this is something, because if you need data, if you want to use R, you need to know how to import your data and then also export your data. So this is it. Very simple. That's nothing else. There's no rocket science here. So it's very simply like, using this one line command. So behind this one line, like I said before, there's thousands of lines someone has like, wrote with all the functions. We just call that function. Okay. Okay. All right. So I think we are done with that section. So we can move on to the next section. So I already shared that PowerPoint presentation with you. I'll give you a minute so that you can start it. Okay, open it up. So download it, and if you haven't done that already, please download the data. I'm sorry, my presentation, and then open it up so that you can copy paste the commands and as we go. Okay, I'm going to give you a minute, okay, just to get ready with the presentation. All right, so I'm assuming we are ready. So data manipulation and cleaning. So when we get a data set, we cannot just run an analysis. There's a lot of work that we have to do. So we usually call this step, like data pre-processing. So which involves a lot of work. Usually most of the researchers, when you work on, especially in social science domain, if you have experience, you probably already know what I'm talking about. You spend a vast majority of analysis time to manipulate data and clean it. So That's like period. It's common for any data set. Usually, real world data sets are really messy, unlike engineering data. So we collect data from machines. As I'm an engineer, so we have really clean data because the machines don't make mistakes. There's no missing data, and it's hard to find. You have smooth data, so you don't have to worry about these issues. But in real world, when you get a data, whether you collect it or someone else did the job for you, it's going to be messy. So that's why we usually call the real world data is messy. So that means the researcher has to spend a lot of time to pre-process the data. This is extremely important because if you don't do this right, you will definitely end up getting something really not useful, right? So when you put garbage into your model, you will take garbage out, right? So you don't need that. So we need to make sure you have a really good data set, precise, accurate, to the best of your ability. Nothing is perfect, but we have to make sure your data is clean and is ready for the analysis. So, like I said before, you can do things from the scratch, manually work on all these things. But usually, data set is not like 10 records, right? So you cannot simply look at like there's 10 people, and then there's like four variables, four questions that you answer. That's not going to be the case. In real world, you're going to have thousands, sometimes even millions of records, and with hundreds of variables, right? So variables, right? So that is when and things get a little bit like complicated. So but thankfully, so thanks to all these people who did all the hard work for us, they have created these packages so that you can simply use whatever they have prepared, just to get it done by writing a couple of lines. Okay.
Dr. Binaka. Sorry to
Yes.
stop. There's a question saying after running the script that we did the last time for saving, I can't seem to find the place I will click to see the data as you did. So I also asked Dr. Opie to share his screenshot, so I'm still waiting for it though. So
Oh,
he can't see the s- the place where you can click the data. Is it in your downloads folder, sir?
no, it's not. So it is going to be in the work directory. So you have to. So basically, like your work directory is the directory that where you save your uh, file. So you can see I'm saving my
Dr.
uh,
Oslo.
yeah. Can you hear me?
Yes, but would you mind sharing your screen so that maybe you can use the pointer?
Oh, I'm
To-
sorry. I'm not sharing my screen. Okay.
Thank you.
Welcome. Yes. Sorry. So all right. So I was talking without sharing my screen all the time.
Yeah, well, just a few for
Few minutes.
yes, sir.
Okay, I'm sorry. Like, please stop me and let me know. Sometimes I forget. There's thousand things in my mind. So forgive me. So I will make sure it won't happen. But please, someone please let me know. So I'm sorry. I thought it's being
Oh,
shared. So
no, you're right. You're sharing your screen.
okay, all right. So right here, so you can see like if you can see where your files are basically like if you didn't assign your file path. So let me undo here. So right here, so we say we are not assigning a file path, right? When you do write CSV, we are not putting the file path. Usually you don't have to do it because you have your workspace. So if you click on here, so you will see like where your workspace is. So in my case, it's C users, my name and desktop, R project, workshop, and then R data. So you have to go to this directory. So it will be there. So trust me, it's gonna be there if you just find the correct directory. It's not going to be in your downloads folder, okay? Because when you don't assign it manually, so it's just going to be saved in your directory, project directory. So your project directory is right here. So if you again once again file or click on open project, don't do anything, just see what the directory is. So it's going to be right here.
Okay.
So yeah, yeah,
Yeah,
this
he said
this
it's good. He
yeah.
wasn't
So
on it.
uh, what did you say, Verna?
He said that he can do it now. So thank you.
Oh, okay, okay, all right. So yes, good. All right. I don't know if I have to repeat what I said earlier, so I may have to, but I don't think if I showed anything. I just started talking about data. So we are what we are going to do is, so we are going to use this package, this like data. So DPLYR is mainly prepared for data manipulation and cleaning. So there's also another step called like data imputation that is also really vast. So some people just do like simple things like, just delete missing records. That is not really like, the right thing to do. A lot of researchers, even the researchers who have a lot of publications and, who work in the statistical domain, they also don't know some of these things actually. Like, ideally, you need to understand what the missing data is, missing data pattern. You have to do some sort of an analysis, and then you have to handle missing data appropriately. So all these things are going to be covered here, but I'm not going to go into advanced topics of like handling missing data because they're a little bit complicated. Okay, so I'll just introduce you like simple imputation techniques. So this is once again, this is one of the main important things in statistics. So if you want to do anything with R or any other platform, any data analysis, like this is not something that you can ignore or pass. Okay, so first thing is like we already have installed this DPLYR package. It's actually is coming under this tidyverse. Like this tidy is just tidying up your data, right? So that's the name that is given by these amazing people who developed this set of packages. Okay, so you install it and then you have the library. So you have to call the library when you open up your R project just to make sure it's being loaded. Um, So yeah, now your library is being loaded here. And then we need to understand the basic principles and syntax. So there's basic functions like select, filter, mutate. So we'll go one by one and try to understand what they do. There's also this pipe operator where we can have multiple operations right in one command line. But I don't think if you have to worry about this right now, because without doing this, you can write it, in many, like several lines and run it. So this, if you find this like, a little bit like, hard to understand, you don't have to worry about that. But anyways, I think I have prepared, all the commands without this, in basic syntax. So again, you don't have to work with this pipe operator. But we have to know what these things do, like selecting and renaming columns. So that's important, because if you get a data set, so the data set might have like, let's say like 10,000, 100,000 records, and maybe there's 100 variables. But in your study, you don't need all those 100 variables, right? You don't need everything, in your like, environment. So that's why you have to just select what you want to select, use in your analysis, the columns. And then you also have to rename. Some of these names won't make sense. You probably don't know what it means. So you might have to go back to the code book. Usually the data comes with the code book. I'm assuming you know all these things, because these are not ours. So these are the basics of, data analysis. So usually when you get a like, code book for a secondary data set, or even a data set that you get it from, from your research team or whoever, so prepare it, they should have a code book that's given. So the code book gives you the definitions of, the column or the variable names, right? So you have to give meaningful names that is meaningful to you, so that you understand what that variable is, right? So that's where these things, select and rename. become really handy. So then you will have your selected variables and they are renamed based on your understanding, so that when you work with this data set using these variables, you know what it means, right? So these things are really important and nobody skips them. So you definitely need to know these things. So so these are the syntaxes to get those things done. So for example, using select function, so you have to just use this function, you see, function, and then you have to give the argument. So the data, and then you have to give the column names. So column 1, column 2, column 3, whatever the column names, you just have to type them. And then this is the first argument is the name of the data set, and then you get a subset, in terms of columns, and then you get the selected data set. So this is how you do that. Okay, the syntax. So it's just one line, very simple. And then this is how you rename columns. Okay, so you just have to type your old column name and the new column name. That's it. So see this syntax. So your first argument, I mean the name of the function is rename. The first argument is data, and then second argument is like the new column name, which is going to be equal to the old column name. And then likewise you can do it for other names, other columns. Okay, so this is how you run it. An example here. So this is one practical example. So let's see how it works in our environment. Please do this with me, because again, these things are really important. We have to make sure you can do this. So I really want you to do this by yourself and see if it's going to work. Okay, so this is again a fabricated data set that I prepared, or else you can use the data set that we saved there. Okay, so when you try this thing, when at leisure, so we try to import that data set and then try to select some columns and then see what it's going to do. Okay, so let's do this. So now this data set, again the same data set that I used earlier. You have ID, name, age, and score, 4 columns, and then 10 rows. So if you run this, so you will see we're going to have, yes, 4 variables and then 10 observations. And now here, using this select command, so function, we are going to uh, select only name and age from this data set. So if I run it, you will see a selected data set is being created with only 2 variables, but with 10 observations. See, so now we have that. So this is the selected data set. This is the other data set, right? So the selected data set only contains name and age. So this is what you're going to do when you get a big data set with a lot of variables. You just have to select whatever the variables that you need using this select function. Okay. And this is how you rename it. So you can rename. I think I have the full example here. So if you just copy and paste this part, because the top part is we already have that. So this is where we rename. Okay, so renaming columns. So what we do here is, we have our data set. It's not the selected data, it's the original data set. Okay, so from the original data set, so age, now we are replacing age years. So we rename it so that we understand it better, right? Name is renamed to full name, even though we don't have full name here. We are just renaming it as full name, hypothetically. So if you run this, you will see, this the original data will have new names. So if, for example, right now, you can see it's ID, name, age, and score, right? So when you change it, let's change, and then you can do the head, and then see what it is. like right here. So now it's saying, instead of name, we see full name. Instead of age, you see age, right? So that's how you get it. This is our new data set with new variables. So when you get your data set, you're going to do the same thing, because I usually do that all the time. I do this because I would like to use, some meaningful names to me. Sometimes the names that those people put, whoever collected the data, is not relevant to your research study. So they use their, variable names, um, according to their research, objective. So maybe it's a different domain, so they may be using different names. In your domain, maybe in your research field, it's a different name. So definitely you have to use this, otherwise you probably would be confused. So it's always important to be clear about all the variable names, otherwise you can mess things up, and then you might do something wrong, or something that you don't want to do. So having those things really clearly written is very important. And then while doing all that, you may have to make notes to yourself and what you're doing. So it's better to put your notes. I mean, you can use this same note file, like right here, the script file, to keep your notes, or else you can go to our markdown and do all the work there. So I can do that. I can show an example later, not now, towards the end of the program. If time permits, we'll see how it is, and then I can show you how to prepare our markdown file. Okay.
Shows error.
Is there a question or something?
Yes, sir, there was a comment. Mine shows error at console. Oh, um,
Doing what while doing something?
yeah, object renamed data not found. But C, can you also show us your entire um the the commands where you started? Okay.
You mean you want to see mine?
No, sir, so Janaka, she sent a message.
Mm-hmm.
I'm just checking what's there. You can see it now, right? What she missed or something.
Okay, so she probably did not run
The type,
the, the previous command. So you have to run, select data command. So that's why the object selected data is not found, because you have to show, maybe you have to show what you have in, the above your console. Maybe you should copy paste the whole thing. So let me show you, like, so
I think it's
please,
the top one here, right?
huh?
Is it DPLYR? I will put it here. The-
Yes.
Yeah, so I put the installed packages in the chat. Thank you.
Okay, welcome.
La-
Okay, all right. So let's continue then. So filter. So filtering, again, this is also really important. You need to filter. So why do we have to filter data? So there's millions of reasons for a researcher to filter data. So depending on your requirements. For example, the original, data set that you have is being collected to, considering a broader population with, lots of different variety of demographics. So, but in your case, you have to select a subsample of that. So you need to know how to filter data. So this is also, again, it is extremely important. Okay. So you can filter data using, many different methods. So for example, you are only interested into, an age group which is, about 25. So this is where, the filter function becomes handy. So you can say, so the syntax of the filter function, is the first argument is data. Second argument, you just have to give the conditions. One after the other, you have to give conditions. So you can give multiple conditions. You can combine conditions and filter data based on that. Okay, so this is the syntax, one example. So you're just filtering the age group of anyone about 25, because that's what your population is. You're not interested into anybody that's age below 25. So this is also a very important function that you need to know when you do data analysis in R. And then you can also combine multiple conditions to filter your data. See, like, so you are selecting ages between, 25 and, age greater than 25 and score greater than 80. So you can also select, ages between 25 and, so 50 or something, because then you can also use this AND condition. So these are the things that you need to try. I mean, you should be able to do these things by yourself. So I really would recommend you to just do these things, experiment, change things and see how these things work. So these things are going to be really important if you're planning to use R for data analysis. And this is the O. See, if you use this symbol, it's going to be O. Okay, so, and then this is not symbol. That's if you use the data, comma, exclamation mark, and then parenthesis, and then age greater than 25. So you put the after exclamation mark, whatever you're saying not, not is like, a logic, logic operation. So you have to put parenthesis there. Okay. So you can also combine multiple logical operators. So you can see, like right here, so we are using a lot of operations here together, right? So, so in this condition, you are saying this, your filtered data should only have, the participants who are 25, older than 25, and they scored more than 80 for the test, and the name should be equal to Alice. So then it will only show people who have named Alice and the scores above 80 and age about 25. So in your filtered data. So this is one example. So let's run this. Please run it with me in your environment. Just copy the whole thing. And then I'm going to clean this. I don't like it when it's messy. Okay. So now this is the same data set. We are using that consistently. And when you, now we are filtering, I actually accidentally ran it. So now you can see we are only selecting, the people who have, who are 25 or above, right? So we can see there's few people here, right? So it's going to be Charlie and also Eve, and then I think it's Grace. Like, likewise, you can see manually see there's 6 people. And if you get the right here, the head, so you'll see all those 6 people. See, Charlie, Eve, Grace, Hank. So their age is about 25. So it's really, really simple. Okay. And then, and then this is applying more than one filter. So, sorry, more than one condition. So combining multiple conditions, the AND operation. You can try that also. We can just copy and paste. So here we are selecting people who are older than 25 and then score above 80. And then if you get head, you will see there's only 4 people like that. Okay. And then this is combining 2 operations like OR condition. So now this should show more people because we are just saying either they should be 25, about 25, or they should have scored more than 80, right? So then you will start seeing more people now. See, there's 9 people because there's going to be like, a lot of people who satisfy either this condition or that, right? When you put an AND condition, it's more restrictive and you will have smaller number of people. All these things depend on your research question and on your objective, right? So you have to define what filters that you're going to use based on your population and your research question. Okay, this is not. Anybody who's not above 25, then they will be selected. So yeah, you please run all these things and see if you know how they work. You can change these values and see what it's going to do. And this has like all multiple conditions. Like there's three conditions that we have included here. Let's see what it's going to give us. There's only 5 people, 5 observations. So it's going to be age greater than 25 and score greater than 80, or name is equal to Alice. So in this case, Alice is going to be selected no matter what her age or score is, because we put that explicitly. We say that because when we put that or condition, you can see, okay, we need to include Alice no matter what. So in that case, other people, everyone else will be like, considered under these conditions. But Alice is exceptionally selected because you have an or condition there. Okay, so Alice will be there, definitely. See, Alice is here. Even though her age is below 25, Alice is included. Okay. All right. So yeah. So I think that try this. Please make sure it's working. If not, let us know. And this is, I think, the comprehensive activity that includes all those things that we did above. So the next thing is mutating. So mutating and summarizing. So what does mutating do? When we mutate, we alter, we create new things. So we change, we create something new. So we change it, we alter it, whatever we have, right? So that's what this does, basically, this function. So you have to create uh, a new variable using an existing variable, um, simply using this function. So that's what we do here. Okay, so we have to give the so this is the new data set, right? So we are going to create a new data set with the new data set name. Usually it's a good practice to create a separate dataset and keep the original dataset intact without doing any change. But you can also replace the original dataset. Let's say, for example, instead of saying this new dataset, if you just use the same data, it will work, but it's going to replace your original dataset. Usually we don't do that because if you import the data, if it has like thousands and hundreds of thousands of records, it takes time to import. So you don't want to go through all that again, right? So you may have lost in some of your files that you already had that CSV file. So it's better to keep the original, and then whenever you do some change, it's better to have a different data set, a copy of data set with a new data set name. So, and the same thing goes here, variable name, new variable name, and then you put the expression. So here is an example. So similar thing, something like this we did earlier. So we are creating a data set, a new data set with a variable name called a score plus 5, where we add 5 to all the scores, right, for everyone. So that's where we use this mutate function. Mm.
Sir, there's a question saying that when they run it, there's the error object not found, object age not found.
Object age not found. Okay. So I don't know. I think they must have selected the wrong data set, or maybe you have to show us a screenshot. Otherwise, with the history of your console, so then only we can say what's wrong. So so you can just copy and paste. For example, if you go to your console, if you want to show So, if there's a problem, you just select. You see, I'm selecting, and then you can copy and then paste it, or else you can send us a screenshot. Then only we can say what's going on.
Thank you. But
Okay. So you basically have to run this thing. So the whole thing right here, data. So if you run all these things, it should ideally work because, like um, if you have the correct environment, I mean, this is just like you need to have the DPLYR installed, and then it should be loaded. In my case, it's already loaded. I don't have to have rerun it all the time. That's why I delete it. But mine, it's already loaded. And then this is the new data set that I created. And then if you don't see this, age variable is not found, that means you probably don't have this data frame properly set up there. So you may have to click on your data right here and see if age variable is there. If not, you have to rerun your script. Okay. Okay. So I hope um, you can do this. Otherwise, let us know.
they said, okay,
Okay.
we're good. Thank you.
Okay. All right. So yeah. So sometimes I don't read the chat, so I know you're monitoring. So yeah, just let me know. I'm ready to stop whenever you want me to stop. So the next thing is summarize. Um, So summarize is basically just summarizing, right? You can find, a summary. Let's say like find the mean score. So or standard deviation, things like that. So you can quickly summarize in an entire data set also. So this is not like something that you widely use, but you can actually. You can use if you would like. So basically, like, you can see again, this is a function, summarize function. You have to give the data set, like, name, and then summary stat, you have to give a name to that variable, and then you have to give the function, whatever the function that you're calling. It could be mean, standard deviation, whatever you want to find. Um, then you just give that with the variable name. Okay, so and then it will summarize. So this is another example doing this mutation and then summarizing. So let's practice that also. Okay. Okay, I'm going to delete all these things because then it's easy for you. So this is the only thing that you need to run, okay, to get these results. So and I'm also going to clear this and clear all these things. And now I'm going to run this. So it will load my data set. I'm consistently using the same data set because then it's easy, right? So I just created it like, a fabricated data set, and it's just the same thing that I'm using everywhere. So so then we don't have to worry about changing anything. So um, now let's see how this mutate function works. So it should create a new variable called score plus 5 by adding 5 to the existing score, right? When you run this. So that's what it did. You can see it created new data variable with 5 variables. So the last variable should be, the variable that has, the score plus 5, right? Yeah, that's it. We got that. All right. So also try um, summarizing. Okay, right here. I really want you to do all these things with me. Okay, so I'm actually gonna probably gonna give you a break, right, Bonus? Should we give a
Yes.
break soon?
Yes, sir. Actually, like if you can break now and we can take 15 minutes, is that okay?
Yeah, so let me run this and then let's take a quick break. I mean, 15 minutes break so that you can catch up and all, whatever is missing. So maybe Ivana can help you, and then I can take a quick water break, and then we'll resume from there. I can come back in 15 minutes, but before that, let's run this. So what this is doing is just gonna give you the summary. So the summary data is just like we are just find the mean score. So you will see just the average score, and then the maximum age. So we have two things we are summarizing it, average score and then the maximum age. So you can see both of those things are included here. So in a data set, so two variables, average score and maximum age. So this can be done if you have multiple columns. You can do the same thing, like for one column you have to find the average, for the next column you have to find the max, right? So these things are really helpful when you have a huge data set where you don't have to manually try to compute everything, right? So you can use these things to get that done. Okay, so why don't we take a break, and I'll be back in 15 minutes.
Thank you.
Welcome.
Oh, sorry.
Okay, all right, thank you. I could not unmute myself. I muted because I had to talk to someone. So that's why I'm back now. All right, so are we ready to start?
We have 1 more minute. Just like
Oh,
if you have questions or anything before Dr. Cosgola begins the session again, he will be happy to answer it for you. And we'll be happy to support you.
yes.
Oh, but before you start, sir, I wanted to share with you some of their comments saying that this is really a very useful session. So they're thanking you for what you're doing.
Okay, you're most welcome. I'm happy to be here. It makes me happy too. I'm glad, it's I'm being somewhat helpful. So I can see this error message. So if you don't have mutate, so I think you have to install function. I'm sorry, install package. You have to get the dplyr install. So I think Werner, do you have my script? So
Yes,
you
I
just
have
have to,
that.
yeah. Okay. So you see, it's showing this because you don't have it installed. So you need that, and then it should run. Okay. All right. So shall we start?
Yes, please. Thank you.
Welcome. All right, so yeah, so this is the entire example that we discussed earlier. I think we ran this, right? So let me see. Yeah, so we did this. Okay, good. Um, so the next step is actually group by function. So this is more like grouping and then summarizing things. For example, let's say you have to uh, group the data set based on age or another demographic, and then you can use this function to group the participants, the records, and then for each group you can summarize. So this function, yes, you might use this, but some people, you just do the analysis, and then through the analysis, you get this kind of demographics, sorry, the demographic based summarizing options. So that's also possible. So we can just do it during the analysis process, or you can actually identify, some of these um, patterns of data. So like, for different age groups, does that, does the score change for each age group, or is it consistent? So, but sometimes you also have to validate certain things in data. So summarizing this way, like, by after grouping by, this the data set can also give you an understanding of any errors. So during this initial pre-processing stage. So either way, this could be useful uh, for you. So this is the simple syntax to do that. So you have to use the group by function and then data, and then you have to give, whatever the variable that you use. You can have multiple variables in group by, so group by age and then group by score. So that's, I mean, in your mind, it's hard to really understand how it does, but I would just say like, okay, you just group by one thing. So right, let's say you just group by age, and then it's actually going to group the data set by age, and it's going to order things. So let's say like all participants, all the records that have a group like age 25, they'll be together. Age 35, they'll be together. So likewise, you can group them by age. So that's about the group by function. And then after grouping by, you can actually summarize using the summarize same function that we used earlier to get um, the mean or whatever that you want to find for each group. Okay, so this is how you use um, summarizing within after grouping the data set, right? So because, first thing uh, that you want to do is you have to group the data. So the group data is there, and then so group data set actually has the order of this group. So the records are ordered so that it satisfies this group. So they're in order. So then if you summarize that group data, it's just going to give um, the summary of that group data, the mean value. Okay, so that's one thing that you can do. So I'm not going to do this because this is not something that we regularly use, but you can just simply copy paste and run it. But you don't have to do this here right now, but you can try it at leisure. So I can just show you. So see, I mean, indeed, I don't have, ages like, let's say like we can change this. Let's say like Alice and Bob. No, let's say we'll change this because I was not prepared to run this. So let's say 23. So now Alice is 23 years old, and then who's this? Bob, Charlie, David, Eve, and then Frank. Frank is also 23 years old. So if you do group by, so what would you expect, right? So Alice and Frank should be like next to each other, right? So, sorry, did we change it? Hold on. Age. Okay, so hold on. I must have deleted it. Yeah. Okay, so the group by function itself is not showing it in order, but when we summarize it, it should actually show that. So because I think I have to add the order by also here. So if we add summarizing, so that will actually summarize for this age group. Okay, let me show you that. So hold on. This is not a function that I have used often. That's why I do not remember how it works, because people usually don't use this thing that much. So let's use this group by data and then try to find the average. So basically, like when you run this, you should be able to get the summary data for that age group. So yes, so now we can see 23-year-old, the average is 83. So see, like 23, Alice is 23 years old, and then you can see her score is 85. And then you have, I changed David's age, 23-year-old. David has 88 score. And then I change age of Alice, Bob, Charlie, Eve, right? Eve's age. So for Eve, she has 1, 2, 3, 4, 5, 80. So if you get the average of 3 of them, you will get 83. So basically, like earlier, like I made a mistake. So it's not going to order by, just because it's grouped by, it's not going to set the order. So you have to also include order by function. Okay, so that's not included here. So it's group by means it's just going to identify, group them in, but it's not going to order them according to the groups, but it will identify the groups. But then if you summarize them, you will definitely see the summarized data for each age group. So like I said before, I actually haven't used this before. So I just wrote it, but I didn't run it. So I thought it would show the outcome, in the order, but it did not show the outcome in the order. But when you summarize it, definitely it's considering that correct order that I mentioned earlier. Okay, so this could be helpful, but I never used it. But I also doubt if you would use it in your analysis. So usually these things you do during your analysis using the functions that you use in those packages. Okay, so let's move on. Okay, so this is the the same thing. So you can see the entire thing is the whole function, it's given here, but I have something else here. So you can run this again. I'm not going to spend time here because like I said before, you probably won't need this that much. But you can try this, play with this and see how it works. Again, like, so what I said earlier, so about the order is not correct. So, but it's just going to identify them and then group them in the computer memory, but without ordering. But when you summarize, it is going to consider that order and then get the summary. Okay, even though the order is not shown, in the group by data, it's going to be considered while summarizing. Okay. All right. So next thing is actually data cleaning. So how do we do this? So like I said earlier, so data cleaning, this is again, and if there's anything that's really important, I tell you. So now you have to pay close attention because this is going to be really important. Most, a lot of people do this right, but some people do not do it right. So you might experience a lot of problems. If you have data, if there's missing in the data, so you can deal with that. There's some things that you'd have to clean, right? So it's some things that you have to remove. certain variables based on, let's say like the responses from 1 to 5. Somebody responds to a question and you get those responses. There's also going to be some invalid responses, right? Computer errors and negative responses that you don't need. So you have to get rid of them, right? So this is where you have the cleaning process. And also you have to take care of missing data. If there's missing data, so you cannot simply ignore them. So you need to take care of them also. So that's what we are going to do now, identify missing values. So how do we identify missing values? So let's see how to do that. Again, it's a simple, easy function you have to run. So function to identify missing values is actually is NA. So NA stands for like not available, right? So basically you can say, okay, if the data is not available, it may be shown as NA, right? So it could also be empty. So so we'll have to deal with all that separately, but you can identify if the data is NA, then this function is going to identify, this is NA function is going to identify if you have any records that contain NA, okay? So, so this will show if there's any missing values, okay? And then you can, if you add some function inside a function, is NA within some function, it's going to give you count the number of missing values. It will show you that also. Okay, so let's try to use this fabricated data. It's a very similar data set, and then try to do that. Okay, all right, so this is my data set. Now you can see I have intentionally left some of these records blank. You see, for Charlie, this time we don't have Charlie's age or score. It's missing. So NA stands for missing records, in this case.
Dr. Cosgola,
Yes.
I have a question. Like, can they also assign a different value to any missing data? So, can NA be replaced?
Yeah, so then you have to use different ways to identify NA. So that's the thing. So we will talk about them later. So so typically NA is the standard missing value notation that we have, that you can easily identify, but there are other functions. So to be honest with you, many people, different people have developed different packages to do the same thing. So so you can use different package or maybe the same package. We have different functions to identify other kinds of missing values. Let's say if it's empty. So usually when you import a data set, if it is empty, so during the importation process, you assign missing values as empty. So in when you in the importation process, so you can handle missing values to assign them as empty, NA or empty. So there's lots of different ways of doing it. So this is just one thing that I'm explaining you. So, but you can handle this in many different ways. So, but is NA is used when you have the standard is NA here. So usually when you import data, if the cell is empty, if it's a CSV file, the cell is empty, during the importation process, you can identify if you want to assign missing values as NA. So usually in R, this is kind of a standard way of identifying missing values. Okay, this is like the most popular way of doing that. Yes, exceptionally, you can use other cases also. Okay, so now we have created the data set. So I have intentionally left these things NA, so not available. And now I'm going to use this function is NA function to identify if there's any missing values in this column. So this column, you see, like this is how you type. So data, and then you use the dollar sign. And when you do use the dollar sign, it will show you all of my columns. See? So data, if you type data is our database, right? I mean, sorry, the data frame. So after that, you type the column name, and then it will consider only that column. So then in that case, the matrix becomes a vector, right? So you see, two-dimensional, like data frame becomes one-dimensional column. So if you just select this and run, it will just show the names, you see right here. So if you just select like age, so this is going to be just age. So what we are going to identify is if there's any missing values in age. Okay, so this is what we find here. So is NA. So you are trying to find out if there's any NA values in this column. So this is that column. Okay, so when after data dollar sign and column name gives you just that column in the data set. Okay, so if you run this, it will identify missing ages right here. So it identified missing ages. It's just going to say true or false. Missing yes, then it's true. If not, it's false. So for example, if you print this, you can see, yeah, so you can clearly see first one is not missing, so that's why it's false. And the second one is not missing, it's false. Likewise, this is true because it's NA, right? So that's what this is NA doing. And then if you do sum inside, if you insert this whole thing within a sum, then it's just going to sum, count how many missing scores are there. So let's do that also. So it's 1L. So that means there's only one record that's missing, right? So it's just one record that's missing. So if you change it, let's say like I'm going to change this also to NA. And now you rerun this. And then you will see there's 2 missing. So hold on, did I do it right? No. Okay. And then missing NA. Sorry, it's not age, score. Okay, it's my bad. So we have to, I'm changing, so age. So this should be age. And for age, there should be 2, right? See, there's 2L. So you can see there's 2 records that are missing. So we have, so scores, there's 2 scores that are missing. Okay, because I made it 2. Okay, so likewise, you can see if there's any missing values, number of missing values can be identified using this. So this is going to be really helpful if you have a huge data set. Okay, so this will be helpful. Identify, especially if there's a really important column that you need, that should not be missing. So you can identify, that column, what is the percentage of missingness. So like, how many records are there, right? So in this case, since there's 2 missing records and we have 10 records, that means there's 20% missingness, right? So likewise, you can identify the percentage of missingness also manually. But like I said earlier, there's like other sophisticated advanced packages that can easily identify the number of missing records, missing data pattern. It can also draw the percentage of missingness in a nice plot, kind of a heat map. and then show you where lots of people have missed to answer certain questions. So there are lots of advanced sophisticated things, but I'm here just teaching you the basics. Okay. So now, how do we handle these missing values? It's a really interesting question. There's lots of different ways, and people even argue, what should I do to handle missing values? I mean, for example, like if you go back to our data set, right? So you look at this. Let's say um, we don't know Ivy's age or score. So what is a reasonable value for Ivy's age and score? Can we assign a reasonable value to to these NA values for Ivy's age and for Ivy's score? Is it reasonable to assign it a guessed value, or maybe can we just get the average of the other participants like age and assign that average age as Ivy's age and do the same for Ivy's score? These are really like kind of debatable, sometimes even controversial. People like fight about these things, they argue about these things, like what's the best approach. So that's why missingness is little complicated. We need to identify, we have to do a good job. We cannot just simply delete records. If it is just a few, yes, we can delete, but if there's lots of records and lots of variables, if you start deleting all the records with missing values, you probably would end up with a really small number of responses. So list-wise deletion is that's what people usually call like list-wise deletion. So that is not the best thing to do. You probably would end up losing a lot of data where like maybe there's like 1,000 people, each person can have missed at least one thing, right? So you're going to miss like a lot of records that way. So still we need to know how to uh, remove missing values, either by replacing or handling it in a different way. So let's see how to do that. So one thing that we can do is we can just omit, remove rows with any missing values. So this is one thing that I explained earlier. So either, I mean, you can say that, list-wise deletion, you can just delete the missing value records easily, or else during the analysis, you can just say na.omit. So when you do that, you can use this within during the analysis, or you can set it like create another data set saying it's clean data set. By using this function, we can remove data that has rows that have missing values. Okay, so this is the example function, like na.omit. So NA is like, missingness, and then dot omit is just ignore it, right? So just take them off. So if you run this, then it will just take off all the missing records. So for example, if you do this, you will see like clean data will only have 7 observations because we have um, three three people who are missing here, right? So as we see here, do we have 3 people? Yes, I think so. Yes. Hold on. Let me rerun this and then see how many. Yes. So there's only 7 observations that we have that's not missing, at least one record. Okay. So here, you can also do something a little bit better, replacing missing values. So this is where, we can use this like, mutate function to alter the data, and then if else function. So if else function is actually that if else condition included in one function. So both of these things are available in dplyr library. Okay, so this is that package that we use. Um, no, you. I also have to tell you something really important. So like you have this package, and there's another package developed by another set of people. They have a different name for the package, but they may be using the same, function name. So you have to be careful when you import libraries, these packages into your environment. Make sure you don't import unnecessary packages, because you might be calling the function in a different library, and then it's going to do something different. So there's obviously explicit ways of calling a function in a given and a specified package, but that is a little bit advanced. I'm not going to talk about that here, but you just import the library that you need. Okay, you don't have to import unnecessary libraries here, because the computer can be confused, because if you whatever the library that you import, it is going to be loaded. All the functions in that library, the package is going to be loaded into the R workspace, your environment. So when you call that function, it could be confused. It wouldn't know like what function to be used. So that would be an issue. Okay. So um, um, so this is the syntax to impute data. So let's see how it works, and I can also explain what it does. So again, like this library thing, if you don't have it installed, make sure you have it installed. We don't have to call it repetitively. This library, it's already there because I haven't left my R. Uh, so I should be good, but I'm gonna just run it. Um, and now we are using mutate, and you can see what we are doing here is what we are doing here is we are trying to have replace age. So what we have here is we have age, as it is. If we have age and then some missing values, right? NA values. So what we do here is we have, if age is not null, let's say that means if it is not NA, then you have to compute. I mean, if it's not missing, you are just going to assign the original age as age. If it is missing, you're going to assign the mean of the age, the entire table. So what you do here is like if else. If else means if this is, you see, like this is where the function starts. If is NA age, what does that mean? Is NA age? That means age is null, right? So then you assign the mean value of age, replacing that NA value, or else you just keep it as age. Okay, so that's what this if else does. So if you don't know how it works, you can type, let's say, if else, and then it will show you, see what it does. So you have to give the test. So see the function example, it's giving you a little example here what to do, right? See, the test is given here, right? So if health function, if you type the function, and on the top there's the pop-up screen is showing you. Let me show you right here. Right here, when you type here, you will see in this area, I'm going to show it because when I annotate, I cannot show you that. But when you type the function, for example, when I type it here, you can see right here, right? If else in this yellow color, if else test is, we are testing is NA, right? This is our test, is NA. So we are checking if it is if the age is missing. If the age is missing, that's the test. Then assign the mean value of age while removing the NA value. Obviously, you cannot compute the mean value if there's NA, right? NA is not a number, right? So it will be an error. So it's computing the mean value of the age column, and assigning it to that, that NA value, replacing. If it is not missing, then just keep it as age. You don't change that. Okay, so that's what you're doing here. So they put this if and else, like that long condition that we had, into one function. You see, like it's easy now, right? So you just have to give these arguments, and then you can easily use it without writing those lines. It's just someone else like made it easy. So again, don't be confused, because there's multiple ways of doing this, because a lot of people have found different ways of doing this, but it's just the same thing, if else function, and then we just mutate, uh, replace it. Okay. Okay, so now, so I accidentally deleted the data. So now I'm going to go back and run this, but I think I should have it in my example. So it should be here, right? Yes, it's right here. So now, as we know, let's put another NA here, and then if we run this, so this is our data set. So I'm going to, instead of saying this is data, I'm going to say imputed. Imputed data. Okay. So if you run this, what would happen? So now it should have assigned, this average age here, right? Average of the rest of the participants' age should be assigned here. The same should be assigned here. So let's see if it has done that or no. Imputed. Yes. So average age is assigned here, 27.125, 27.125 is assigned. You can see that. So that's the average, right? So you can do the same thing for the score also. So let's say, so you do the same thing. So now we use score instead of age, okay? So we check if the age, assign the age, if, sorry, the score is null, that means NA. So then you get the average of score, and then assign it as the score. Otherwise, you just keep the score as it is without changing. Okay. So if you do that, then you should see the average score assigned to all the participants. So does this make sense, and is it reasonable? It could be reasonable. I mean, obviously, like when we have thousands of data, right? So assigning the average score to the missing, participants could be reasonable, because this participant may have some other additional information. Let's say like this person is missing the score, but this person has responded to everything else. So like removing this person's response, like the entire data from the data set, could not be the best thing to do, because we are losing all the other responses of this person just because we don't have the score, right? So in that case, it's actually reasonable to assign the mean value of the rest of the participants as this person's score, and then move on without deleting that record. Okay, so that's something that that you can keep in mind. Okay, all right. So if you want to do this like this, it should actually do it for the entire data set for both of them. So now you have no missing values. Age is fixed, and then the score is fixed. So you can say you can simply take care of the missing values this way. Okay. I think there are a lot more advanced methods of doing this. I'm not going to cover all of that because it's actually beyond this introductory score. I mean the cost and we need a lot of time to do those things. It's basically like it takes like one semester to teach about missing data and how to handle missing data. It's a very advanced topic. So just for you to be aware that there's before we handle missing data, so it's a standard practice to understand what the missingness is. So if you are interested, you can do like more research on like understanding the missing data. So there's tests that you can do to understand what is the reason for missingness. Sometimes the data is missing because people don't want to respond to some questions. Sometimes the missingness happens just because of randomness, because people sometimes forget, sometimes they randomly skip. But some questions, they purposely avoid responding because there's sometimes some questions are actually kind of stigmatizing, or maybe they don't want to like respond because it's traumatizing because of some of their past experiences. I don't want to respond to that question. So it's things like that. So missingness, you have to identify, understand the reason for missingness. So we perform a test called like Little's MCAR test to check if the data is missing completely and random. So then if it is missing completely and random, then you can actually do the imputation. But if the data is not missing completely at random, then you have a problem. So there's a reason for missingness, and then we have to identify the reason before we handle. So if you impute the missing data without knowing the reason for the missingness, then we could be biased when it comes to the analysis. That's why we have to be really careful when we handle missing data, because it's a very sensitive topic. Most of the time, many researchers don't really handle that properly, mostly because a lot of them don't know these things exist. Okay, so those are the advanced topics. And then we have in R, there's a really nice package called mice. So like it's basically like um, it's a, I don't know if I have it imported here. It takes a lot of time to install. So it's actually mice package. So this is a great package. So I may have it installed, but yeah, so I have it installed because I have used it here. So this package is the most advanced missing data handling package that I have seen anywhere. So this I know M plus has some good functionality, but this is actually mm, best, the best actually. I would say one of the best. Any other statistical software, they don't have this, because basically mice package can handle missingness really well. So it can impute data using very advanced machine learning algorithms. Just by learning the patterns of data, it can really identify this NA value. What is the best value to assign for this missing value based on the rest of the responses of the participants and the responses of similar participants. So these are really advanced things that you don't want to look at right now, but I really want you to know these things also exist. Okay, so that's why I told you. So these are I mean, when you learn more, um, most of these things you can actually study by yourself. So if you get the fundamentals, the rest is easy. So you just know how to learn something advanced at that point. Okay, so my target here is actually to give you the basics, and also be aware that these kind of advanced tools are there so that you can do, especially if you do very sensitive research. If you have a really sensitive data set, so you need to be careful if there's missing data. Okay, so you cannot just simply randomly delete or even do imputation simply by using some of these methods. You have to handle it properly. Okay, so for some reason, these things we have already covered. I don't know why I'm seeing, I probably must have made the same mistake. Maybe I have copied it. twice, but we already covered these parts. Okay, so yeah, so the last thing is actually creating a flag for missing values. So that we haven't discussed. So I don't know if, where did I do this? Hold on 1 second. Yes, okay, oh, sorry. So other strategies to handle missing data. So yes, imputation, I already explained that, mean, median, and also advanced imputation techniques like, the mice package we can use. I already explained the mean imputation with a good example. And flagging. Flagging is just actually, just flagging means just identify what, the missing records and then flag them. So basically you create another variable saying that, okay, so age is missing. So you have an age flag if age is missing. So simply put a flag there. So when you analyze the data, so you use this flag variable to really omit the records that have missing age or whatever you want to do. Okay, so that's another thing that you can do. This is also, it's not my favorite thing. I don't like this way. I mean, you don't have to really, flag this variable. You just put a condition in your analysis. If age is missing, do not do it, right? So this is, I feel like it's kind of redundant, but some people do these things. That's fine. That's why I included that here. So that's not necessary. But I think, yeah, I think these things we covered. We don't have to, yeah, we did all this. All right. So this is a complete example. I think it's just the same thing that you can try again. All right. So the next topic is actually data types conversions. So yeah, this is also another really important thing because certain data types that you have with you may need to be converted into other types to properly handle them and analyze them. Especially when you import data, like especially most of these things happen when you use a secondary data that's being collected by someone else and you just use their data and then they have their own data types that they used. So during the importation process, you just see the data type that they assigned for. But when you do the analysis, that data type is not compatible and it's incorrect. So you have to consider now what the type of the data is. So as you already know, again, I'm assuming different types of data, like that when it comes to the computer, inside the computer that we store data with in different types, like integer, float, string, and then also within R itself you have different formats, like factors also. So for example, when you collect data, you will see some data are continuous, some data are categorical, some data are string type, right? So I'm assuming you know what I'm talking about. So if the data is categorical, that means usually in surveys, when people respond to a question, let's say like from 1 to 5 scale, what is your response, right? So just you have 5 different responses, like starting from 1 to 5. So people would choose their response, right? It could be ordered categorical, or it could be just like regular unordered categorical. So so that could be the case. So either way, you have categorical data, and then you have continuous data where you have age is considered as a continuous data. So and test scores are considered as continuous data. So it could be multiple things that you have in your data set. There's Name is a string data, like type. So it could be a little bit overwhelming to identify what these data types are and how to handle them properly. Especially when it comes to analysis, you might find it really challenging because certain types of modeling, for example, linear regression model or logistic regression, so they can only handle certain types of data. And if you use the wrong data type, it might work, but you are doing something wrong. So you cannot consider categorical data as continuous or vice versa, um, because you need to treat them right. So a scale, or we also call this, scale is the measure, right? So measure is a scale. The scale, usually we have this categorical data in a Likert scale, or whatever the scale that you use is important. Sometimes the order matters, nominal or ordered, or however you have the categorical data, you need to be really careful. So you have to go back to the code, where it gives the original responses, the question and the respond. So you really have to read everything. So whatever the variables that you use, you need to go back to the code book and then see, what are the questions, what are the responses that the participant responded to, and then you have to identify, what are the responses? Are they ordered? Are they categorical? Are they binary? Or discrete or binary is the same thing. So then only you can identify what type of data it is. So then you can proceed with, this kind of conversion process in case you need it. Okay. So um, so these are some of the examples that I mean, the reasons that I prepared, for the why we need to convert the data. I already explained the most important reasons for you. So common types of conversions are given right here. So so in R, so we have factors and characters. So so characters are usually like, we have them in, like, like in a string form or something, some kind of a form that computer identified, and then we can factorize them. So factors are like, they're categorical. So you put them into categories based on um, uh, these categories that we have in characters. Okay, so that's one thing that we can we usually do. So we can look at this. You see, like factor, category, factor, and then you have this variable, and then um, we'll see when we do the conversion what happens. Okay, so let's try to get this data set. Okay. Okay. So now, so you can see ID is this person's identification, and then person's category, right? So now, um, so you have these things as factors, and now you want to have them as characters. So this function called as character is going to convert factor or any other variable as a character. So if you run this, it should be converted as characters. So now it doesn't show here the change, but when you do the analysis, it will be considered as characters. Okay, so these are like the functions that you're going to use to convert certain data types into characters. So if you can also reverse the process, if you want to consider them as like factors, again that category can be converted into factors using as factors. So it's going to convert. So, but again, like I said before, it's not going to be visible here. But when you assign them as factors, it's actually going to give them a factor here. So factor is like a number to identify each category. So then when you run your like regression, like, let's say like if it is logistic regression, it's going to be binary. So it's either 1 or 2, 0 or 1, right? So in that case, it will be considered as like, A as 0, B as 1, or let's say like A as 1, B as 2, and then C is 3. So likewise, it will be considered that way. So when we do, like right now, you may not understand what I'm saying, but when we do, like, do the modeling part, I'll explain this, how to really take care of this well. So right now, you may not understand what I'm talking, but I just wanted to show you like these kind of conversions can be done. And then integer. So sometimes we have to identify some variables as integers, especially if you're going to do any mathematical calculation. Um, then we need to identify them as like integers. So sometimes this maybe when you import them, maybe they're just like they're just strings. So in that case, you may have hard time to do any analysis. I mean, ID, you're not going to do any analysis, but this is just for an example. I wanted to show you this is how it works. So now it's just an integer, but you won't again see any difference here. But the storage, in the computer storage, the computer is going to identify this as a different data type because it's going to convert it into a different data format or within the computer binary scale when it is stored. Okay, it could be 32, 16, 64, whatever that in that scale, it's going to be converted. And then you can convert, back to characters from an integer. So all these things can be done here. Okay, so let me see. Yeah. Okay, so I think it's better if we continue the rest tomorrow. Werner, I feel like we did enough for the
I
day today.
I agree, sir. I was about to suggest it the same. And but before we go, there is another kudos to you, saying thank you for the good job. And we are very appreciative and grateful um for
Yeah.
your time. And I know Dr. Cosgola will not be happy on me saying this, but you know that he's doing this out of the goodness of his heart, purely voluntary. So we appreciate him very much. Um, Thank you again, Dr.
Yeah, yes.
Paula. And before we go, let me just make some announcements so that we are um, all on the same page. Again, we will send you guys the a copy. Well, now you have the PowerPoint, so please review it just so you will have a copy. You now have a copy of both slides 1 and slides 2. So the first day and the second day, if there are information that you missed, please review it and try to practice on your own. So this is a skills-based workshop, and we get better as we practice. I will also send you the YouTube link for the video tomorrow within probably 8 to 10 hours. You have to forgive Caleb and I. So it's almost 11 p.m. in our where we are. And for me, I haven't had dinner, so this is something that we can